Hello everybody, this is Fernando for the latest aliens and UFOs video. Alright, let's go ahead and let's continue the wonderful book UFO Sightings by Alan Baker. This one starting a whole new chapter, chapter 12, but as it turns out, this will be the final chapter associated with this book. Yes indeed, everything does come to an end, and with this fantastic book, this will be the actual final chapter for it. But it's going to be a long chapter, so it's going to be over several parts still. But what a wonderful book so far. Lots of great evidence and encounters associated with both aliens and UFOs, and lots of intriguing ideas. We talked about Men in Black as well, and then we talked about government agencies and various encounters that people have had with them. So this final chapter seems to sum things up and then present some new topics as well. But the chapter is called Conclusion, the UFO Phenomenon, Origin Unknown? Question mark. So let's go ahead and let's start the first segment here, and then I'll give my own thoughts and opinions. Hope y'all like this book as much as I have, and then once this book is finished, I'm going to start another one soon. But this is the first segment. It's called Faster Than Light Interstellar Travel. Here's what it says. In the 5 decades since Kenneth Arnold's sighting near Mount Rainier, one of the cornerstones of the skeptics' arguments against the extraterrestrial hypothesis for genuine UFOs has been the impossibility of faster than light travel. The distances between the stars are so colossal, they say, that it would take thousands of years for any spacefaring civilization to traverse the gulfs between even the nearer stars. Thus, it would be far too wasteful in terms of both time and resources to make a habit of interstellar flight. To speculate at any length on the developments and propulsion that might be achieved by an advanced alien civilization is beyond the scope of this book. Instead, let us look briefly at the developments in our own understanding of physics, which seem to refute the often made claim that faster than light travel is and will always be out of the question. In this way, we might at least begin by association to refute the skeptic's central claim that hypothetical aliens could not visit us because we cannot visit them. It is indeed impossible for a spacecraft to travel faster than the speed of light by means of known propulsion systems. This is due to relativistic mass increase, which means that the faster a body travels, the greater its mass becomes. Although Albert Einstein's theory of special relativity established him as the central figure in early 20th century physics, the relations which he derived to explain the behavior of space, time, and matter within a moving reference frame were originally derived by a Dutch physicist named Hendrik Lorentz through different means. For this reason, they are called the Lorentz transformations. In his 1988 book, Faster Than Light, Superluminal Loopholes in the Physics, the American physicist Dr. Nick Herbert summarizes the Lorentz transformations as follows. The Lorentz transformations predict 4 major changes that objects in a moving frame seem to undergo as viewed from a fixed frame. Number 1, space shrinks in the direction of motion, which is called Lorentz contraction. Number 2, time slows down, otherwise known as time dilation. Number 3, clock desynchronize, otherwise relativity of simultaneity or sync shift. And number 4, mass increases in the moving frame. Herbert goes on to explain that at low speeds compared to that of light, the Lorentz transformations are insignificant. However, as light speed is approached, the transformations increase by an amount proportional to the Einstein factor. The Einstein factor is equal to 1 for low velocities, is equal to 2 for 90% of light speed, and increases to 7 at 99% of light speed, and becomes infinite at light speed itself. Thus, the mass of a spacecraft accelerating towards the speed of light would increase, presenting increased resistance to further acceleration. Not only would the energy of the propulsion system be usurped by the increasing mass, but at the speed of light itself, the mass would become infinite. Therefore, the amount of energy required to reach the speed of light would be infinite. In short, the spacecraft would have to carry an infinite amount of fuel capable of delivering an infinite amount of thrust. To give some idea of the size of this problem, Herbert describes the behavior of electrons inside a television set, which are accelerated to 30% of light speed. For these electrons, which paint the picture you see on your screen, the Einstein factor is about 1.05, and they are 5% heavier than electrons outside the television. Electrons in a linear accelerator, on the other hand, move a great deal faster. For instance, the mass of an electron passing through the Stanford Linear Accelerator would increase by an Einstein factor of 50,000. So a bullet traveling as fast as a Stanford Linear Accelerator electron would weigh as much as a dump truck. It can therefore be seen that travel beyond the light barrier will never be achieved through brute force. As Herbert states, more artful strategies are needed. However, by their very nature, these strategies are not amenable to easy utilization, and there are many false leads. Instances where FTL travel actually occurs, but which are of little help in powering a hypothetical starship. One such instance of faster-than-light travel involves, believe it or not, radio waves. Herbert describes how at the turn of the century, radio engineers discovered an astonishing property of these waves, which, although they travel at the speed of light, are capable of exceeding that limit. The reason for this is related to the behavior of a beam of light passing between two transparent media of different densities. If a beam is traveling from a high speed to a low speed medium, for example, from air to glass, it bends downward at the interface. Conversely, if it is traveling from a medium where speed is slow, i.e. glass, to one where it is high, i.e. air, it bends upward at the interface. However, for incident angles greater than a certain critical angle, the light beam, for a slow into fast situation, instead of bending, doesn't even penetrate the second medium, but reflects from the interface as if it were from a perfect mirror. This phenomenon of total reflection is characteristic only of the slow into fast situation and never occurs in the fast into slow case. The speed of light in water is 75% of that in a vacuum, and in air is in 99% of vacuum speed, and thus results in total reflection in certain instances. For example, when the surface of an ocean appears as an undulating mirror to a diver below. When radio engineers discovered that ionized gas totally reflects radio waves, their inexplicable or inescapable conclusion was that since phenomenon only occurs from a slow to a fast medium, and since radio waves already travel at the speed of light, the waves had to be traveling faster than light in the ionized medium. Bizarre as this conclusion sounds, it does not violate Einstein's universal speed limit. To explain this, Herbert uses the analogy of a stone dropped into a perfectly still pond. The result, of course, is an expanding circular band, but within the band are smaller ripples moving from its trailing edge to its leading edge at about twice the speed. The velocity of these smaller ripples is called phase velocity. The velocity of the band itself is called group velocity. What those pioneering radio engineers had detected was the phase velocity within the radio waves, which were traveling faster than light and thus were totally reflected by the ionized medium. Unfortunately, the group velocity of radio waves never violates Einstein's speed limit, even though the phase velocity does so with ease. Thus, although faster-than-light travel is possible within radio waves under certain conditions, for example, when they are bounced off of the Earth's ionosphere, the group velocity remains at light speed and cannot be used to carry a signal faster than light. So much for faster-than-light phase waves. It would seem that we will have to look elsewhere for clues as to how we might one day bypass the apparently impossible light barrier and journey to the stars. The mysterious, almost magical realm of quantum theory might just hold such clues, since it describes, among other things, a curious phenomenon known as quantum tunneling, in which particles can move from one location to another without traversing the space between them. Another notion is the quantum connection, which suggests, in Herbert's word, that once two quantum systems have briefly interacted, they remain in some sense forever connected by instantaneous link, a link whose effects are undiminished by interposed shielding or distance. This continued instantaneous interaction seems to occur as a result of the mathematical probability waves, which represent the quantum systems and which do not exist in normal three-dimensional space, but rather in what is called configuration space, which contains three dimensions for each particle. According to Herbert, the quantum wave for a two-particle system, for instance, moves in a six-dimensional space. Herbert likens this faster-than-light quantum connection to the workings of voodoo, in that an action on one particle instantly affects the other particle because they leave parts of themselves with each other with each other during their initial interaction and are still in contact with each other through those parts. Many science fiction writers have used the notion of tachyon in their faster-than-light star drives. Once again, we can turn to Nick Herbert for a summary of the properties of these hypothetical particles and the differences between them and tardions, slower-than-light particles, and zero-mass luxons, particles that travel at the speed of light, only three of which are currently known: protons, neutrinos, and hypothetical gravitations. Number one, a tachyon possesses an imaginary rest mass. That is, the square of its mass is a negative number. Number two, as it loses energy, a tachyon speeds up, a result already anticipated by Sommerfeld in 1904. Once a tachyon has lost all its energy, it must travel at an infinite velocity. That is, it occupies every point along its trajectory at the same time. Alexa Myron Boluntz and E.C. George Sanderson, authors of an early treatise on tachyons, call a particle that dwell in this strange state of omnipresence, zero energy, infinite velocity, a transcendent tachyon. Number three, to slow a tachyon down requires the addition of energy. To slow a tachyon down to light speed requires an infinite quantity of energy. Thus, a tachyon, the speed of light, is a lower limit to its velocity. Once a tachyon, always a tachyon, such particles can never go slower than light. And that's it. Let's go ahead and let's pause it here as we go about this part one associated with the final chapter, the conclusion of this book, UFO Sightings by Alan Baker, the conclusion being titled The UFO Phenomenon, Origin Unknown. There it is, talking about faster than light travel. Interesting stuff. So you and I have both seen movies and TV shows that deal with it. Event Horizon comes to mind on the movie side, and then pretty much any Star Trek episode comes to mind on the TV side. You see them basically use methods to be able to travel faster than light. Star Wars is another one that stands out too. And on their end, they obviously use movie magic, like when it comes to having light speed, warp speed, and so on. Like it's the idea that hyperspace, that they can just move from point A to point B at much traveler than light. But as the book explains here, if you're using conventional methods involving energy, you need infinite energy in order to go to infinite speed. And the problem is, the faster you go, as the book explains, the more mass that you become. It reminds me of something I remember hearing as a child, and it's interesting when it comes to dinosaurs. The theory was, why do dinosaurs stop at a certain height, right? Like some of them reach really tall heights, like the Brachiosaurus and Gigantosaurus and others. Why did they not grow even bigger? But it turns out the more larger a dinosaur is, the gravity on Earth causes them to have more mass required on their legs, to the point where if they were like a mile high, their legs would be so big that they would be immovable. And then obviously the species dies out. So that's essentially the medium, the level that it found when it came to that. So it's kind of like here, when it comes to faster than light travel, you need something else to be able to do so if you're just using traditional means of acceleration. Event Horizon, I liked how they pointed it out in that excellent movie, how essentially they're just cutting the space in between. They're moving from point A to point B, but they're joining those points together, and that's how they move. And then, of course, in the Star Trek, Star Wars world, they use different methods to do so and get there in a much faster time. So the idea, if aliens are out there, how do they exist if it involves faster than light travel? If we don't have it, to me, that just means nothing, because obviously it's a different world, it's different technology. They've conquered something that allows them to be able to do it, and just because we can't do it doesn't mean they can. It ties into another a corny like example, but it's a good movie still. The Avengers movie, Captain America's shield was indestructible, right? Always indestructible, can never be broken. And yet there was Thanos breaking it during the final battle. As it turns out, it's because the material in his sword, even though on Earth, whatever Captain America's shield is made of is the most indestructible thing in the world, that's our world. And Thanos' world, his material in his sword is even stronger than the material on our world. So it was easy as that. That's why he was able to break that shield. So if we can't travel faster than light, why would that stop any other world from being able to achieve it? They found something, so they've been able to do it. But let me know what you guys think. All right, everybody. Thanks again as always. Take care. Bye.